Alright, let's start with the demo. Here I'm running an AI workload inside an Intel TDX confidential VM on Azure, secured by Thales CipherTrust transparent encryption. Right. So the first part is about CipherTrust CTE registration and attestation. You can see CipherTrust has registered the client, and the Intel TDX attestation is complete. This proves the workload is running inside a verified confidential compute environment, not just a regular VM. Next, I create a policy tied to this workload. It enforces encryption and identity-based access control, so only authorized service or user account and processors can see the sensitive data in clear. Now let's test the user access. Here I log in as an authorized user. Notice that the AI pipeline can read the PDF and text documents in clear form. Alright, so this is a secure happy path. The model gets the data it needs. Now the data volume mounted by an unauthorized user, in this case privileged root user, look completely different. Instead of readable content, all they see CipherTrust, and this is a zero trust enforcement in action. Data is protected, even the storage is exposed. So that's the demo. Let's step back and look at why Intel TDX matters and how it compares with AMD SEV-SNP on GCP. So firstly, Intel TDX provides a hardware-based memory encryption for VMs, protecting data in use, not just at rest or in transit. It includes attestation so that we can prove the workload only run on trusted hosts. This is critical for AI training and inference where sensitive dataset lives in memory. With TDX, enterprise can move this workload to Azure with confidence and end-to-end protection. On Azure, we can deploy pipelines directly inside TDX-enabled VMs, layer CTE end-to-end encryption, and control keys externally with CipherTrust manager. This means customer keeps sovereignty over their keys while still benefiting from confidential compute in the cloud. Now let's look at Intel TDX and AMD SEV-SNP, two cornerstone technology in confidential compute. Both encrypt the entire VM memory and isolated it from hypervisor and host OS, keep sensitive data and AI models protected even in the shared cloud environment. They implement hardware-based memory isolation with attestation, so the cloud verifies trust before any workload runs. Intel TDX goes further to enable customer-controlled attestation for sovereign and regulated workloads. Thales CipherTrust adds unified key management, policy control, and audit visibility across such platforms. Simply put, Intel-based clouds or customer attestation choose Intel TDX. AMD-based cloud choose SEV-SNP. So whether you are running AI pipelines on Azure with Intel TDX or on GCP with AMD, the story is the same. Confidential compute protects the data in use. CipherTrust protects the data everywhere and give you the strong key control, and customers stay in control. That is secure AI by design.